Hi, my name is Kathleen Brandis, and I'm a software engineer on the Spot team. Today, we're going to be going through the second presentation of payloads. The first presentation by Marco and Devin gave an overview of how payloads work with Spot, and this presentation is going to be a deep dive into integrating your sensor with the Spot SDK. Specifically, we're going to be working with a USB webcam and integrating it with the Boston Dynamics API available on our open source GitHub. These ideas presented today will be generalizable to other sensors. So we're going to start on a developer laptop, since testing and integrating your example will be a little bit easier there before jumping to the robot. But later in the presentation, we'll walk through how to run it on Spot and the Spot core on robot. And at the end, we'll have a fully integrated webcam, which you can see in tablet during teleop and AutoWalk. So today we're assuming that all of your prerequisites are installed, which involves Python as well as our API wheels. You can walk through the quick start guide on our Boston Dynamics dev.bostondynamics.com website for how to install these. And that will show you how to set everything up. Additionally, you can access the examples in the source code on our open source repo. The examples shown today are in our 2.1 software release. So let's jump right in and first test our webcam. For a Linux laptop, webcams and cameras show up in dev/video source. So my laptop has a built-in webcam, which will be available at dev/video 0. However, when I plug in the USB webcam, we can see that at dev/video 1, we now see a source, which is the USB webcam plugged into the laptop. And we can further test this by running cheese, which shows the output of our USB webcam. And we see that it's working. So we're all set from the hardware front on our camera. Next, let's also test that we can communicate with our robot, Spot. So I'm going to choose our network. We're running on beta 34 and attempt to ping the robot over Wi-Fi. When we have a successful ping, we'll see a network runtime, which here we're seeing a couple milliseconds per ping, which is great. That means we're talking with the robot. Let's also make sure we can access its web page. So I'm going to log in to the robot's web page, and we see everything as expected. We can go check out our payloads and see the Spot core registered already. Lastly, let's also test that the API is working. So I'm going to use the command line client and run ID, which will show our software version as well as pieces of information about the robot software running. Great, so we now have a working communication with the robot and a working webcam. So let's do a brief overview of payloads and how they work in the API before we jump into actually running the webcam on the robot in our developer laptop. We're going to be running the webcam example on the Spot core, which is a compute payload for Spot. There are two ports that the Spot core can be attached to on the robot, the rear port and the front port. The rear port has a different IP address than the front port. Additionally, we'll be plugging our webcam into one of the multiple USB ports on the back of the Spot core. In the API, a payload can be either a sensor, like our webcam, or also a compute unit, like the Spot core, or our developer laptop. For testing from a developer laptop, we want to register it as a weightless payload so that it can communicate with the services on robot but does not affect the gate by adding weight to the robot that isn't actually there. So to do that, we'll use the payloads example. This will set up a unique identifier to represent our payload. This is used and referred to as a GUID in the API, and it will also provide a secret, which is like your password, but for our payloads. So we can go to the payloads example in the API, which registers this weightless payload named client registration example number 1. And it also shows us what our GUID is and our secret. These two pieces of information will be useful when we actually run the webcam example. Now we can switch over to the command line and actually run this example. So the arguments here are similar to many of our other examples running from a developer laptop. We'll provide the username and password of the robot and the host IP of the robot. And when we run this example, we'll see the different payloads that are registered with the robot, as well as our newly registered weightless payload, representing our laptop's connection. And lastly, we have to make sure we authorize these payloads on the web page. Otherwise, they won't actually be able to communicate with Spot. So now that we've set that up, we have our GUID available on the web page, and we know that this laptop will be able to communicate with different services on the robot as a payload would, which is all we need for our example. Now we can go ahead and jump into the webcam example and actually run it. So if I go over to the webcam example directory, we can see the different files here. The run webcam service file is the file that's going to launch our webcam service and set it up to communicate with Spot through the payloads. We can get our laptop's IP address using IP_show, which is going to be used as the host IP argument. As well, we need the GUID and secret as arguments on the command line for the webcam example. This, in addition with our IP address for the laptop, tells Spot where to communicate when it's trying to talk to the webcam image service. Lastly, we'll provide the robot's host name as an argument and a device name. This device name is used as the image source. So as we looked at earlier, we're going to provide dev video 1 to tell it to communicate with the webcam and not our computer's built-in webcam. We see the output starting thread of dev video 1. That means that the webcam is successfully being communicated to within the example, and everything is working great. Next, we can also check that it's working by going to the tablet and seeing the output on the tablet. I see the webcam source available with the list of camera sources, and I can see a live output on the tablet of the webcam. So everything is running great from our developer laptop. Let's talk about exactly what's happening behind the scenes. So the Spot SDK and API is built as a number of different network services. Each service has multiple different commands. So for example, the power service has commands to power on and off the robot, as well as monitor the power state. These services are built through gRPC, which is a widely used network service library and one we use to communicate with the robot. Our payloads can also register services. These act identical to the services on robot, other than the fact that they're running on a different computer. Our webcam is going to be running from a payload computer as a service on the robot. And we can test and see these services through the command line using the command line client's dir list example. This will show us all of the services communicating with Spot, both those running on robot as well as those running on the payload. This command line example uses the standard arguments of username and password as well as the robot's IP address, and will provide the arguments dir list to tell the robot, please list all of the directory services. Here we can see that output. We see all of the different services available on robot, such as the robot state service or the robot command service, which we can tell Spot to stand up and sit down in. We also see our webcam service, which is still running. And that service is registered as an image service, which is a specific type of service on the robot. We can learn more about what is in that image service by going to dev.bostondynamics.com and looking at the documentation. So here we see there are two different commands, or RPCs, for the image service. There's the list image sources and the get image requests. These RPCs are used to communicate with our webcam service or any other image service of this type and tell the robot, first, about which sources are available, and second, about how to get these images. You can further see the different requests and responses, which are specific protobuf messages. These are what the commands use to talk back and forth between the robot and your application. And now, when we look specifically at the webcam example, we can see that that's implementing the image service as well. It's called Image Service Servicer, which is just the gRPC terminology for how we're running the service. And we can see exactly those commands. The list image sources command, where we're outputting the sources specified by that argument device name, and the get image command, where we're responding with the available images. This get image command and different commands within services act as the bridge between our hardware API and the robot's gRPC communication API. Here we're talking OpenCV to communicate with the USB webcam. However, other pieces of hardware might use a different communication protocol. As well, we use an image capture thread in the background. This is an optimization that we made for the webcam so that we can respond quickly to different get image requests. We have a loop that continually requests the images from the robot and stores them in a buffer so that when you call get image, you receive an image back almost immediately rather than having to wait. As well, in this loop, we register service faults, which notify the robot about issues, and for us, we'll notify if a camera is not connected. And Piro will talk about service faults a little bit later. So now that we have a successfully working webcam example running on our developer laptop, let's transitioning to running it on robot. Piro is going to talk about how we can run it on robot and Dockerize the example.
Thanks, Kathleen. Hi everyone, I'm Piro Lera, and next we're going to talk about how to take the example that we just described and running on the Spot core, which is the compute platform for Spot. All these applications that we're discussing and concepts can work on the Spot core, but everything can be applicable to any type of other compute platforms that you can attach to Spot. We'll do this, as Kathleen mentioned, by Dockerizing the example first. And there's a few example reasons why we're Dockerizing this application. First is that it's a widely usable platform and technology that it simplifies the packaging of an application and simplifies the deployment process. It also allows us to do all the application development, debugging on the development laptop, and then package the whole requirements and application environment into a Docker container so that it's running the exact same application in the same exact way onto the Spot core itself. Also, it allows us to limit the chance that there is conflicts between running this application on the Spot core with the other applications that are already running on, that could be running on the Spot core itself. And then thirdly, it's as part of 2.1, we're introducing a very easy way to move this Docker image from creating it on your development laptop into the Spot core. But also as part of 2.1, we're introducing Portainer.io type of web application so that any user can simply just load the Docker image and then copy into the Spot core, create the container, run it, and monitor how it's performing. So to do that, you need to have a Docker file, and the example itself in the Spot SDK already contains a Docker file necessary to create the Docker image. And it contains a few very simple applications. So first, you have the instructions on what base image you need to use. And in that case, this is one that's already created with Python and OpenCV. These are the requirements that are necessary to run the example. Next, we also copy the requirements file that specifies what Spot SDK wheels and packages are necessary to install into this Docker image in order to run the application, the webcam application. And lastly, it's the entry point on when you start the Docker container, what application to run. So this would be the same exact script that is run locally for running the webcam example. And next, we also can provide some documentation in terms of how to build, save, and run locally the Docker image. So we want to make sure that when we create the Docker image, it runs correctly on the local laptop and verify that it's the exact same way that the actual Python application runs. So the examples for that, first we start with Docker build, and then after that, that's the application that simply just builds the Docker image. And next, we're going to work on saving the Docker image. So this is the command for saving it. And that will create a tar file that we can simply copy from the developer laptop into the Spot core, as we'll see in the next step. And lastly, we'll make sure that it runs correctly into as part of the Docker image, but run it locally and verify that everything works the same way as the example itself. Next, what we're going to do is transfer this Docker image that we created into the Spot core. And as mentioned earlier, there's two ways to do that. One is through command line tools, SCP Docker commands, but also through Portainer.io, which is what we're going to focus today in this demo. So in the Portainer.io application, we're going to go into the Images tab and select to import the tar file that we created with the Docker image necessary to load. So we're going to select that file. and this is the one that we just saved from the previous step. And this step will take a few minutes on the regular application. For now, we'll skip it through. So we'll upload that into the Portainer.io portal, and that will create the actual Docker image that's necessary to run on Spot Core. Next, we're going to create and configure the container from that image. So we'll go into the Containers tab, and we see that we have the image loaded into Portainer for that web application. And so to create the container, we're going to give it a name, in this case, webcam, a simple name to match what we need to do. And most importantly, we need to focus on and select the webcam tar file that specifies the image that we just loaded. We need to randomize the ports. And next, we have to configure how we're going to run the Docker container. So first is the command itself. So these are the application parameters that were used locally to run the webcam example. Same thing, we have to copy them so that the Docker container, when it runs, it specifies these same arguments to the application. So this is the GUID, the secret, and the host IP and the host port. So we'll copy them into the command here. The one thing that changes is the host IP and the host port, and the IP in this case for the robot. 50.3 is the internal robot IP, and 50.5 is the Spot Core IP. So that's a little different from what we did earlier. Next, we're going to change the network as well to be host, again, not to have any issues with port forwarding between the Spot Core and the container itself. And lastly, we're going to add the device itself. So this is the video USB camera that is attached to Spot Core, and we need to forward it to the container itself. So this is dev0 video 0, and it's specified on the host in the Spot Core, and that's forwarded to the container as dev video 0 as well. And finally, we simply just deploy the container, and we'll see it run it as part of the web application. So when you click on it, this is also showing that you can look at the logs themselves on what's going on. So this would be easy for, and we'll see later, on where developers can go and take a look to see if anything is going wrong. Okay. Next, we're going to focus on making sure that this works correctly on the tablet. And simply, we're going to create an auto walk mission. So auto walk is our functionality to create missions and with the Spot robot and replay them later on. So we'll use this webcam example running on the Spot Core to collect an image and then replay it and make sure that the robot does the same exact thing. So now that the container for webcam is working correctly and running, we're going to verify that the tablet is showing the webcam feed correctly. So for that, we're going to switch into webcam view, and this is already working given that the container is running, and we see the Spot with the webcam source right away on the tablet itself, and we can control the robot. And next, we're going to create a mission through AutoWalk. So the tablet will allow us to record a mission that will capture an image from the webcam example that's running on the container. And then we'll replay that mission and verify that the data is captured correctly and download it on the tablet and visualized at the end. So to do that, we switch from Drive into AutoWalk functionality, and we're going to record a mission. To do that, we need a fiducial in view, and in which case we have one already available. So the left camera is detecting the fiducial, and you can see it in purple. So we can start recording the mission right away. And we're going to simply just move the robot forward and make a collection request for the webcam, which is connected to the example that's running on the container. And to create it, you can also specify user metadata if you'd like to attach to this image, but we're going to skip that for now. So we're going to confirm. And this is calling the webcam example that's running on Spot Core, collecting one image from that camera, and recording it as part of the mission. So next, we're going to save the mission. And this will allow us to revert and replay the mission. So if we click this button, the robot will move back into the spot where it started the mission from. and move forward again. And when it gets to the end, it's going to capture the image from the webcam example running. And when the mission is done, you'll get this notification on the tablet. So you click the Done button, and we can download the data. So again, this could be done through the tablet under the hamburger menu. So download data. You can get any length for data to download, but in this case, we're simply just going to download the information that was captured from login up to now. So we'll click the download button, and it was only 2 images. So to verify that that worked correctly, we'll go into the files view. And this just shows that there's an image.8.zip. So this is the zip file with the images that were just downloaded from the robot. So to unzip it, and we see that there's 2 JPEGs being collected from it, and we'll verify that those look correctly. So this was the images 8 folder. And the reason there's 2 is one is from the mission being recorded, so that was a teleop, and the second one being from the mission being replayed. So to verify, this is the image that was taken when we recorded the mission, and this is the hallway that we see, and it was collected from the webcam example. And same thing on the other folder. So this is the mission being replayed. So same structure, we see the video 0.jpg, and it's the same exact image being collected as part of the mission replay. So this shows that the mission replay and the auto walk functionality work correctly with our webcam example. So this is connecting a USB camera, recording a mission with the capture that collects one image, and then being able to replay that mission, capture the same type of imagery from that webcam example, and being able to download that data and visualize it on the tablet. What we've shown so far is that everything works correctly when there's no issues on the code, or if anything happens on the hardware side. Next, we're going to focus also on what happens when errors occurs in the software, or any hardware issues that can come up. And there's 2 different ways to verify that things are working correctly and see if there's any errors are shown in the system. One is through making sure that there's no developer logs, and these are available through the Portainer.io logs, as we saw earlier. And the second part is operators can also see if there's any faults being raised by any of the hardware or software that's running on the robot. 2 different ways of visualizing errors. So the errors themselves on the logs are more for developer purposes. So the developers who are familiar with the code base can understand if there's any issues at the low level. But operators who might not be as familiar with the code base can easily see from the tablet if there's any faults that are being raised from the software or from the hardware itself. And we'll visualize that. In this case, we'll unplug the camera from the Spot core and see what happens in that case. So this is a view of the tablet itself, and Kathleen is going to unplug the camera from the USB camera from the Spot core and see that the tablet itself is going to show errors being raised and faults being raised from the service itself. And you see the active service fault is 1. So if you open that up, it shows that the image capture failure happened 15 seconds ago when Kathleen disconnected the camera. And this is the webcam service that we're running on the Spot core, showing that it cannot connect with the Dev Video 0, which is the USB device where the webcam was connected. So this is very useful for operator level type issues and verifying that things are working correctly. And as mentioned earlier, developers can also take a look at more detailed logs on the Portainer.io portal to see if the code base itself or the software is sending any errors into the log folder itself. So we'll switch into the Portainer logs, and we can see that there is a lot of errors being shown by the application itself, the webcam application, that's saying that it cannot connect to the device, given that we disconnected it from the Spot core. And next, to wrap up, we have shown that we have a fully working example that simply we ran on the developer laptop first, and then we moved into the Spot core. And we showed that it worked with the teleop and as well as the auto walk missions. So we created a mission, we replayed it, and verified that it can connect to this new USB web camera that we connected to Spot core. And this case handles all the successes correctly, as well as any errors that are happening from the hardware itself or from the software issues. And to recap, what we do in the whole example and demo was that first we installed the Spot SDK on the development machine. And then next we, as a developer, we write the code to register as a payload, and then also create the functionality to act as an image service. And Kathleen mentioned what the commands are that are necessary to implement in that case. Next, we test and debug on the development machine, where it's very easy to make changes, do quick iterations to verify that the code is working correctly, and debug any issues found. The next step was to Dockerize the example. So we want to verify that we can run it as part of a Docker image. And first, we test it and verify that it works locally on our development machine. And then we copy that Docker image that was tested into the Spot core itself. And we deployed that through, you can do it through the command line, but also you can do it through Portainer.io to make it very easy for users of any technical level to be able to deploy those Docker images on the Spot core. Then we verify that we test and debug on the Spot core, same way that we do that on the development laptop. And lastly, we use the logs as well as the payload faults to verify that things are working correctly, or if there's any errors that are being raised by the hardware or the software itself. So we talked about a USB webcam connected through this example, but these ideas are generalized to any type of image sources as well. This could be thermal cameras, can be machine learning or image processing type applications that can generate images. And so this example and many others are available through the 2.1 Spot SDK, and hopefully everything was very useful to you today, and you learned how to use the Spot SDK together with the examples and how to connect them to Spot and verify that everything works correctly. Thank you for your everything, and goodbye.